math. Today we're going to talk about verifying trig identities. I like these better than the simplify questions because at least I know where I'm trying to get to. But the thing students have trouble with is they want to work with both sides. Okay, so it says I can combine trig expressions by getting a common denominator and simplifying to a single expression or fraction. I can verify a trig identity working with only one side, showing clear steps to prove the identity. We did a warm-up question, so we're going to go on to this. All right, it says to verify an identity means to prove that both sides are equal for all values of x. This is done by transforming the expression on one side of the identity into the expression on the other side. You can only work with one side of an identity question. If you make changes to both sides, it will instantly become a concept error. All right. You must show all steps very clearly so that I can follow what you did. Do not assume that Hofbauer can crawl into your brain and understand what you were thinking. So this is an example that's done on your notes. They traded a secant squared minus 1 for a tangent squared. Then they changed the top and bottom into sines and cosines. Then they multiplied by the reciprocal of the denominator, and the cosine squared canceled, so the left-hand side became equal to the right-hand side. You may always choose to work with either side, but on a problem like this, I would always choose the icky one to try to simplify down to the other one. Does that make sense? And if you get stuck, switch and try the other one sometimes, but okay, what do you want to try here? Left side, right side? Okay, so let's work with the left. We're not going to mess with the right. What do you want to change secant to?
1 over cosine.
Okay, so we have 1 over cosine minus cosine. I can follow that step. Then what do you want to try? Common denominator, maybe? Okay. When you show that you are getting a common denominator, you must show me that you are multiplying by 1. You cannot show me that I'm just going to multiply the top, okay? The common denominator here needs to be cosine, so I'm going to multiply this by a cosine over a cosine. You have to show that. So then what do I get? The common denominator is now cosine of theta. You can show that in one step, but what is the top?
1 minus cosine squared.
1 minus cosine squared. Good job. What is a 1 minus cosine squared? This is a Pythagorean identity. It is a sine squared. Okay. Now, anybody know how we can make this into a sine times a tangent? The sine squared is a sine times a sine, right?
So we factor out as
Well, we're really not factoring. Can we just say that that's equal to that? And then what is that saying? Sine over cosine is? And it should be a theta. I have x's and thetas. That's really cool, Hofbauer, but really wrong. Not that I would count it wrong on a quiz. But yes, they should all be thetas, not a mixture of both. All right, and then when you get to the bottom, you say this is now equal to, and a lot of teachers will say you could just write the right-hand side. Or you could just show that I got it equal to what it was up at the top, whatever. Questions? All right, we're gonna try number 2. Which side do you wanna try this side, this time? Yeah, I would probably try the right-hand side and make it simplify down. We're trying to get it to simplify to just secant. So we have the sine of theta Want to go with sines and cosines? Or tangent would be sine over cosine. Cotangent would be cosine over sine. If I distribute this, what happens? I get a sine squared over cosine plus a sine times cosine over sine, which would be just a cosine, right? Then what? Before I can add them or do anything else, I need a common denominator. So you must show how you got the common denominator. What am I going to multiply this one by?
Cosine.
No. You can tell me cosine over cosine,
Oh.
right? But it's got to be a form of 1. I was just making an example. You are probably going to write that down anyway, but you can't just say I'm going to multiply by one thing. It's got to be a form of 1. So cosine over cosine. So then I have a sine squared plus what happens up here? I get a cosine squared, right? And the common denominator is cosine. What happens then? You write yourself a little note that this is a Pythagorean identity, and it becomes 1 over cosine, which is secant of theta, which equals the left-hand side that we started with. How you doing, sweetie? Do you want to go to the nurse? I think you're supposed to pinch up here, but
Yeah.
I can send you to the nurse.
What's the nurse gonna do?
Well,
Ice pack.
yeah, something. She'll.
Just perishing in the back corner.
She's bleeding out.
Don't say that. Is her last name McKinney?
Mackenzie. Don't ask me how to spell it.
That's all right. We'll fake something.
Just write it really scribbly like a doctor. They'll assume that.
Here you go. Can you get yourself there? You're not feeling dizzy or anything? Okay,
You're running it really
there you
good.
go. All right. Number 3. I'm thinking left side, yes? Can you try this one on your own real quick? Change to sines and cosines and see if everything divides out. I'm thinking this is super easy one, maybe. Maybe?
Let's see.
Okay. Divide, 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 divide. 1 equals 1, right?
Yeah.
There might be one easier than the other, for sure.
I like.
Actually, more likely that I would put that on as a simplify question without the equals 1 on there. Say simplify, and you would just trade it all and go, oh, it's just 1.
That'd be great.
Just because I think simplify, when it simplifies down to something that easy, that's pretty clear where you should stop. Okay, we gonna try the left side? Okay, cosecant is 1 over sine is being divided by cosine over sine. Okay, I already got thetas and x's going. And tangent is sine over cosine. Ideas?
Yeah, the bottom part one thing first.
What?
You have to make it into one fraction first.
Okay, we can make the bottom into 1 fraction first. To do that, we'll need a common denominator on the bottom. So this will have to multiply by
Sine
cosine over cosine. And this one will have to multiply by sine over sine. I'm sorry, that is so crooked. So the top is still 1 over sine x, which is being divided by the bottom. What happened to the bottom?
Cosine squared plus sine squared all over cosine sine.
Okay, the top was a cosine squared plus a sine squared, and in the denominator, we have a cosine and a sine. Okay, this is a Pythagorean identity and trades out to be 1. And then we could rewrite divide as what? Multiply by the reciprocal. What's left? Or the right-hand side. Later, when you look at your notes, you're going to go, what is LHS, RH? It's just left-hand side or right-hand side. Everybody good? Did you get all that? All right, number 5. I'm thinking the left-hand side needs a common denominator, yes? So, I'm going to write 1 over sine y minus 1 minus 1 over sine y plus 1. Now, what do I need to multiply the first one by? Sine y plus 1 over sine y plus 1. And the second one I need to multiply by sine y minus 1 over sine y minus 1. Because it is a proof, just like in geometry, there was silly things you had to do in the proof that didn't seem redundant. Like, remember when you had to write reflexive? You're doing side angle side or something, you had, okay, you've got to show all the steps. You got to show me that you're getting a common denominator. So now the common denominator has sine y minus 1 times sine y plus 1. What's up top, though? If I distribute a 1 here, I just have sine y plus 1. But what happens back here? This was a negative 1. So it's a minus sine y, and then this is a plus 1. Okay, so the top becomes what? Sine y plus 1 minus sine y plus 1 is 2. What can we do down on the bottom?
Sine squared.
Yes, we can FOIL it together. Sine squared of y plus a sine y minus a sine y minus 1. The middle two terms would cancel out. So I have a sine squared minus 1. Now, the Pythagorean identity says cosine squared plus sine squared equals 1.
If you move the 1 over and then move the cosine over.
Okay, so if I made this sine squared minus 1, by subtracting it over here, I'd have to subtract that over there and I'd get a negative cosine squared. So this is a Pythagorean identity rearranged. We get a 2 over a negative cosine squared. What do they want us to get?
Negative 2 secant squared.
Okay. What if I pull out a negative of this and a 2? What's left? I took out the 2, that'd be a 1. I took out a negative, that would be cosine squared. And what is 1 over cosine squared? Uh-huh, uh-huh.
What's wrong?
Shall we try the right-hand side? Okay. A 1 times a sine, this is one term right here, right? It's like an xy, right? It's two things multiplied together. So 1 times a sine x would be a sine x. And 1 times this guy back here would be a negative cosine of x. Then what? If I distribute this, what do I get?
Fun.
Sine x cosine x times sine x. Sine squared times a cosine. Or cosine times a sine squared, either way. Okay, now I have a mess because I didn't leave room. Okay, now I'm doing this big mess times this back here. So it's negative. Sine x cosine squared. Okay. How excited are we?
Like, never too many spots in this one.
Let's go back to number 3. I like that.
Let's go back to number 3. Let's ask for.
Oh, I know what we were supposed to do. I mean, we should be able to go from here. No terms cancel out. But oh, I know what we can do. Maybe. Yes. What if we put these two terms next to each other? I'm going to show you what we should have done in a minute here. And I will solemnly swear not to put this on a quiz, okay? I'm going to put those two next to each other. And then I'm going to put plus sine squared x cosine of x minus cosine of x. So then I put this one and this one, but I switch the order. What can I take out of these first two?
Sine?
What would be left if I took a sine out of both of those?
Cosine.
No.
1 in cosine squared.
1 minus cosine squared. Yes?
Yes.
Plus, what can I take out of these two back here?
Cosine. 1.
And left will be a sine squared minus 1. All right, what is the Pythagorean trade for this one? So I have a sine x times a sine squared. Okay, what is the Pythagorean trade for this one? Be careful, it's not cosine squared. Yes, it's negative cosine squared. So we wind up with a sine cubed x minus a cosine cubed of x. Okay. What we probably should have done, anybody remember the difference of cube pattern? We could have factored this left-hand side. I'll just go through it real fast. It would have factored sine of x minus cosine of x times, and then you square each of those, so it's sine squared, and then it's remember, it's the opposite of these together, which would be a plus sine cosine. And then it's plus cosine squared. Well, what is a sine squared plus a cosine squared, guys? So in this parenthesis back here, you'd have a 1 plus a sine times a cosine. And in this parenthesis up here, you'd have a sine minus a cosine. Is that not the same thing, but just in a different order than this? Okay, so if you remembered how to factor cubes, okay, hereby solemnly swear neither method will be required, okay? That was just gross. All right, yeah, it was much better. All right, what do you want to try on 7? What do we got left here? 7, 8, graphing, 12 minutes, okay. You want to work with the left side, I think, right? So tangent would be sine over cosine plus cosine over 1 plus sine. Okay, now what?
1 plus sine.
Common denominators? I think we're going to have to. So we're going to multiply this by a 1 plus sine over a 1 plus sine. And we're going to multiply this side by a cosine over a cosine. So the new denominator has a cosine times the quantity 1 plus sine. And what happens up here? Can I distribute that now, or you want me to write it out and then distribute it? So sine times 1 would be sine. Sine times sine would be, and back here, cosine times cosine would be, oh, I think this is a beautiful problem. Because what is sine squared plus cosine squared? So Pythagorean identity right there leads us to a sine theta plus 1 all over a cosine times a 1 plus sine theta. Well,
1 plus sine theta?
yes, because it doesn't matter what order we add in, right? So this entire quantity divides out this entire quantity, and we are left with 1 over cosine, which is secant. That one wasn't as bad as I thought it was going to be. I feel like this is much the same. What do you think? I can do it real fast if you want, but what are you going to multiply this one by? Sine over sine? This is a 1 plus cosine, and it's currently over a sine, so we're going to have to multiply it by what? Yes, a 1 plus cosine over 1 plus cosine. So the common denominator has a sine and a 1 plus cosine. What happens to the first two when we multiply the numerator together? We just get a sine squared. Back here, we have to FOIL. Can we do that at this point right now? 1 times 1 would be 1. 1 times cosine would be, cosine times 1 would be another cosine. And then cosine times cosine would be cosine squared. Anybody see anything exciting up top? Yeah, sine squared plus a cosine squared. We are allowed to add in any order we want, right? So those together make what?
One plus
So we have a 1 plus another 1 plus a cosine plus another cosine.
all over sine.
Sine times 1 plus cosine. What does the top simplify to?
2 plus
2 plus 2 cosine.
2. Those cancel out.
Kind of, but I think we need to do something to make that clear first.
Separate.
What could we do to the top?
1 plus cos.
Take out a 2, then it will say what?
1 plus cosine.
I would never FOIL the denominator or multiply the denominator together unless something was going to cancel. I would just leave it factored. 1 plus cosine over 1 plus cosine is 2 over sine, or 2 times the quantity 1 over sine, which would be 2 cosecant. Is that what we were supposed to get? I don't know, it was so long ago, I can't even find it.
Yeah.
Okay,
That was
all right. We're gonna do some graphing, so grab your calculator and make sure you are in what mode for graphing? Not degrees. For graphing trig functions, you need to be in radians. Okay, radians. Okay. Use the graphing calculator to test whether this is an identity. If it appears to be, verify it. If not, find a value for which both sides are not equal. So on your calculator, how would you put in cosecant? 1 divided by sine, and then it says minus sine. If you want to put extra parentheses, you can. It would do the right order anyway. And you need a sign of x. You need to put an x in there. Close, close. And then it was what? Minus sine of x? Okay. And we're going to go down to the second one. And how do we put in a cotangent? 1 over tangent. So I'm going to put an extra parenthesis just to safeguard us. Whoa, not 2 x's, 1 x and a parenthesis. Extra parenthesis, okay. And then it said minus, or times cosine, right? Times, not minus, get rid of the minus half power, times cosine of x. All right, I'm going to set my window. I'm in radians, so what's a good window? Not 0 to 90. I told you to graph this. We could probably do negative 10 to 10, but what do we graph in, guys? When we graph sine and cosine, we graph in terms of pi, right? Like 2 pi, negative 2 pi. So I might do negative 2 pi to 2 pi. On the one you have to graph on the quiz, I tell you the window to use for x. I don't think the y is going to be very big, so I'm just going to go like negative 5 to 5. All right. Yep, my calculator is not in radians. Okay, now it should be working. Did you get this? Are they the same? My beautiful colored calculator clearly showed, right, that they turned blue and then they went back over the top in red. So they are the same. So then we're supposed to do a proof and show that they're the same. I'm going to run out of time, so I'm going to, here's the proof, right? Let's try this one. So the left-hand side Sine plus cosine cotangent. What did I just say? Sine x plus cosine of x times 1 divided by tangent, right? Doesn't it say cotangent? Okay, my window should work. There's the first one coming through. I don't see the second one at all. That's because I didn't put the second one in. Okay, it's supposed to equal secant, which is what? 1 over cosine? Okay, try again. There's the blue one, there's the red one. Are these equal? No. Cosecant. Oh, it should be 1 over sine. Yep, this one should be sine. Does that make them equal? Yes, it does. All right. By the way, if you put in a squared, you need to close the parenthesis and then put the squared on the outside. Here's the assignment. It is 7 questions. Probably the last one of which is graphing would be my guess. But you have it in the packet.